Let's try one more recursion sequence and finding the first few terms. In this example, our first term is going to be 64, but to find the nth term, we're going to take the previous term and multiply it by a fourth. So a fourth of 64 is 16, and a fourth of 16 is 4. Now we can easily see that we're multiplying by the same thing every time, making this a geometric sequence. Alright, in part C, let's find an expression, an explicit expression for the nth term. We remember that with a geometric sequence, the nth term will be the first term times the common ratio to the n minus 1th power. So for us, the first term is 64, and our common ratio is 1/4. So we can leave the expression just like that. In part D, we need to find what the 10th term is. That's as simple as just plugging in 10 and plug it in for n. 10 minus 1 is 9, so I'll take that to the 9th power and grab my calculator. Ooh, I don't really like what it tells me. When I plug it all in, I hit enter, I get 2.44 times 10 to the negative 4th. We know how to deal with scientific notation. That would be 1, 2, 3, 4, 10 to the negative 4th, 4, 4. But we could also make it converted into a fraction for us by doing math, enter, enter, and the fraction is 1 over 4,096. Since this sequence is geometric, to find the sum of n terms, I'm going to grab my geometric formula, which is first term minus first term times common ratio to the nth power over 1 minus common ratio. So let's start plugging in what we know. Our first term is 64. The common ratio in this case is 1/4. We saw that we were multiplying every term by this 1/4. And then since we're finding the sum of n terms, we'll take it to the nth power. Now there's really not much that I want to do to clean this up. Maybe just simplify the denominator, but leave that numerator 64 times 64 minus a fourth to the nth. 1 minus a fourth is 3/4. And as far as typing things in the calculator is going to go, it might be nicer to use 0.25 and 0.75. But let's save that for the last part. In the last part, we need to find S. S. Not S sub 10, not S sub 20 or anything like that, just S. What that means is to find the sum of infinitely many terms. So this thing has to be a geometric sequence or series, and the common ratio has to be less than 1. We already know it is geometric, and we know the common ratio is a fourth, so we're good. The sum of an infinite series is a1 over 1 minus r. So we just grab that 64 over 1 minus the common ratio of a fourth. So this is 64 divided by 3/4, like I said, is 0.75. And go ahead, grab the calculator, calculate it out, and you'll get 85 and 1/3. There you go.